Good afternoon, guys. So welcome back to my channel. This is Mr. Chen again. So welcome back. So today I would like to talk about 4.3. Again, this one is showing that 3.3. It's a different textbook that I was using before for pre-calculus. And today's lesson is all about the properties of logarithm. So previously for 4.2, I talked about that a little bit for the natural log for the property. It's about like power to coefficients, all that. So this one is quite similar. So the first one, it's also called a power to coefficient. But this one is just for like a general log, L-O-G. So anytime they see the power n written like this, you can always bring it to the front. So it's written as n times log base b of x. So power to coefficient. And then the other one is the product to sum. So you see that log base b, x, y. So this one we can expand it. So log base b of x plus log base b of y. So the condensed form on the left hand side versus the expanded form on the right hand side. So product to sum. So again, this one is the exact same property, the one that we went over in Algebra 2 last year. And then this one, quotient to difference. So log base b of x over y equals log base b of x minus log base b of y. So quotient to difference. Okay, so now for the rest of this, so let me just put it to the new slide. So just want to show you that the way to apply the property. So the way to expand and the way to condense. So using the property back and forth. Okay, let me put it right here. So started with the first one, a. So the common base obviously is 2. So it's log base 2. Numerator, so this one we do have a and x to the power. So normally people like to bring down the power to the front first. Okay, that's fine. So 5 times log base 2 of the quantity ax over y. And now from here you want to expand it. So 5 times the quantity of log base 2, 8, plus log base 2 x minus log base 2 y. So what I did here, I just applied that, not just the power to coefficient, but product to sum, and then quotient to difference. So one thing that we noticed, log base 2 of 8 is like log base 2 of 2 to the power of 3. So that one is just like log base 2 of 2, it's 1 times 3, so that's just 3. So we found 5 times 3 plus log base 2 of x minus log base 2 of y. And then obviously you want to distribute, so it's 15 plus 5 log base 2x minus 5 log base 2y, like that. Okay, so there's so many properties that I can apply, not just power to sum, product to power to coefficient, power to coefficients, product to sum, but also quotient to difference. So basically I just apply all those 3 properties within the same problem. Okay, so now what about for the next one? The next one is quite similar. So this one, the base is 10. So this one is all considered product. So what we can find out here is log base 10. So started off with 20 to the power of x, and then plus log base 10, and then times x squared, y, the quantity to the power of 7. So basically you can just start it off with the product to sum with that 20 and that the quantity x squared times y. And now from here, bring down the power to coefficient, so log base 10 of 20. And then right here, so it's log base 10 of, well, so many things that I can put in here. So distribute the power, so we got 2 times 7, then that'd be 14. Y to the power of 7. So bring down the power also for those terms. And also we can expand it. So plus 14 log base 10 x plus 7 log base 10 y, like that. Okay. And then for the natural log, this one can be written as natural log of quantity x squared minus 1 to the power of 1/3. So bring down the power first. So 1/3 natural log of x squared minus 1. And for those you might be wondering, what about that x squared minus 1? We can simplify it a little bit more, because that one is the difference of 2 squared. And also try to expand it. So I'll put it right here. So it's 1/3 natural log of x minus 1 plus natural log of x plus 1. And then distribute. So it looks like this one just bring down the power, but don't forget about the factoring. The factoring can put it like a product of the conjugate. Okay, so plus 1/3 natural log of x plus 1. So just like that. And then for the other one, the logarithmic function. So this one, basically we can take out something out first, like x squared or x to the 4th power. Okay, so for these, it's kind of interesting. Okay, so let's do it right here. Oops, just want to get more space. Okay, so eraser, that's what I want. Here we go. You know what, let's do this. Okay, so for D, so this one can be written as log base x squared. So take out the greatest common factor, so we do have 2x to the power 4. Okay, so take out the greatest common factor first. And then what we found out here, it's just x squared minus 2x plus 1. So trying to factor this out, so this one is log base x squared to the power, well, not to the power, x base x squared of 2x to the power 4. So x squared minus 2x plus 1, so then that would be considered x minus 1 quantity squared. And now from here you want to expand it. So log base x squared of 2 plus log base x squared x to the 4th power, and then plus log base x squared of x minus 1 quantity squared. So just like that. Another thing that we can do, so let's see, the power, the exponents, all those things. So it looks like we can separate them. So we've got to be very careful with the structure. So this one looks like nothing we can do because x squared is the base. Okay, you might be wondering 2 of 2, log base 2, well that's not considered log base 2 of 2 because that the base is x squared. So this one basically just keep it that way, log base x squared of 2. But this part right here, got to be careful. So this one is like log base x squared of x squared plus log of x squared and then x squared again, because x to the power 4 you can split it x squared times x squared, so we can expand it. And one thing that we notice, this one is just like 1 plus 1, which is 2, so plus 2. And then this part right here, and you might be wondering, can we expand this one? Yeah, we can, but the thing is that it's a trinomial factor. So basically this one, just keep it as the way it is. So log base x squared of x minus 1 quantity squared. Okay, so for that, the final result. So this one, x is greater than 1, it just shows the restriction. So it got to be greater than 1, because this whole thing right here, we need to satisfy the domain must be greater than 0. If that's less than, got to be greater than 1. Because it's quadratic, so it set up the base, you know, it's like a VA, so it must be greater than 1. Okay, so now going back to the template, and let's see what else that we have. Okay, what about condensing? Okay, for number 2. Okay, so once again, just want to take this one to the new slide. Okay, so condensing, let's see. Okay, so what we found here, it's 2 log 2 natural log of x plus 2. So going backwards, so the coefficient, we can put it back as a power. So natural log of x plus 2 quantity squared. And then minus natural log of x minus 3 minus natural log of 2. So this one is all difference, so that means difference through quotient. So natural log of x plus 2 quantity squared over x minus 3, and then also over 2, because that is minus. So in other words, 2 times this quantity. Okay, so eventually this one, let's see, anything that we can simplify. So it's natural log of the whole quantity x plus 2 quantity squared all over 2 times x minus 3. I mean, the denominator you probably want to distribute, but just keep it that way. Condensing. And this one's quite similar. So log base 4 of x to the power of 1/3 minus log base 4 of y to the power of 1/3. And you might be wondering, there's no log here for 4. So that one can be written as log base 4 of 4 to the power of 4. Because 4 is just like log base 4 of 4. Okay, so log base 4 of 4, it's just 1. Okay, and now, so you'll be able to condense all of them together. So log base 4, x to the power of 1/3 over y to the power of 1/3, and then times 4 to the power of 4, which is what? 64 times 4. $256. So what we found here is log base 4, 256, and then x over y to the power of 1/3. Just like that. Condensed form. Okay, so now let's see what else that we have for the rest of this. So solving. Well, this one is also another one to expand. So just follow through it and then find out and solve for the equation. Okay, so for number 3, so expand that natural log of f of x. So f of x is 2 to the power of 2x. Okay, so natural log for this one, 2 to the power of 2x. X squared minus 3x plus 2, looks like that one is factorable. So consider x minus, well, x minus 2, x minus 1. Okay, and leave the answer in the simplest form. Okay, expand it out. So this one, basically just consider natural log of 2 to the power of 2x plus natural log of x minus 2 plus natural log of x minus 1, and then 2x, bring it to the front. So 2x times natural log of 2 plus natural log of x minus 2 plus natural log of x plus 1. Minus 1, excuse me. And you might be wondering, the 2, can I put it back here as the power? So it's like 2 to the power of 2, which is 4. You can do it that way too. So it can be written as x natural log of 4 plus natural log of x minus 2 plus natural log of x minus 1. And then solve for the equations. So this one is like 2 to the power of 2x plus 2 to the power of x plus 1 minus 24. So this one, try to rewrite it. It's just like 2 to the power of x quantity squared, and then plus 2 to the power of x plus 1. It's just like 2 times 2 to the power of x minus 24, and that equals 0. So again, so for part B, you want to set y equals 2 to the power of x. So try to solve for y first. So we got y squared plus 2y minus 24 equals 0. So y minus 4, and then y plus 6. So y equals 4, and then y equals negative 6. But this one, it's exponential functions. So for that, y equals 2 to the power of x, exponential growth model. So it cannot be a negative number. So it can only be a positive number. 2 to the power of x equals 4. And then solve for x, so x got to be 2. Yeah, so that one is not that bad. It's just like complicated, tedious. And then another property that we need to know is that the change of base formula. So anytime they see that log base b of x, so it's always considered log base, the common base a of x over log of common base a of b. Or it can be written as log x over log of b, or log of base 10 of x over log of base 10 of b. Or it could be written as natural log of x over natural log of b. It's the same ratio. So, but this one, applying for that, a got to be greater than 0, a cannot be 1, and b and x must be greater than 0 for those restrictions. So find out the change of base formula for log of 6/15. So given 3 different possibilities. So it could be written as log of 15 over log of 6. It could be written as natural log of 15 over natural log of 6. And also it could be written as log of base 10, just like that one, or log of base a. Okay, so log of base a, 15, over log of base a, 6. So where a must be greater than 0, and also cannot be 1. Alright, and now let's see what else. Find the value of log of 1 over 16x by using the change of base formula. So one thing that we know, log of base 2 of x equals 0.75. And now we need to find out log base of 1 over 16 of x. Okay, so it's one of the interesting one. So whatever that's given, that means we need to apply the given value. So log of base 2x, so that equals 3 over 4. So in other words, this one, that means 2 to the power of 3, 4. So that equals x. Back to the exponential form. So what this one is showing, that it's log of 1 over 16 of 2 to the power of 3, 4. Okay, so basically it's 3, 4. Bring the 3, 4 to the front. Log of 1 over 16, 2. So 1 over 16, that's considered 2 to the power of 2 to the power of negative 4. Okay, so let's find out what log of base 1 over 16 of 2 is. So that one is just like 1 over 16 to the power of x. So that equals 2. So in other words, it's like 2 to the power of negative 4x equals 2. So that means x equals negative 1/4. Okay, so that means this whole thing right here, it's negative 1/4. So 3, 4 times negative 1/4. So negative 3 over 16. So this one is like bunch of like substitution that I need to put in for this. Okay, so what I did first, convert that to a fraction with that 0.75, and then convert the log form back to the exponential form, and try to find out the expression for x. So for that, evaluations, log base of 1 over 16x, instead of using x right there, so simply plugging that 2 to the power of 3, 4. And one thing that I noticed, 1 over 16 and 2, so those are even number, so that means they can be written with the same base, the common base. So what I did, I convert that into from the log form to the exponential form. So 1 over 16 to the power of x equals 2. So find the common base, which is 2. So 1 over 16 is written as 2 to the power of negative 4x. Compare that with that power 1, so negative 4x equals 1, x equals negative 1/4. So negative 1/4 times 3, 4, negative 3 over 16. And now the rest of this is all about making a graph, exponential model, and then inverse, and also the absolute value. Finding the inverses, swapping the variables, simplifying, condensing, expanding, all that, or finding using the properties of logarithm. Okay, let's do some of the problem here. So this one can be written as y equals negative e to the power of x minus 2 plus 1. And you may notice that the value of k is 1, which is the horizontal asymptote, because that it's an exponential model. And the value of the base is e, a is negative 1, so that means it's going to be reflected over the x-axis. And the value, well, let's just identify that a is negative 1, h is negative 2, b is e, and then k is 1. And also using the xy table, get some points. So x equals 2. So we got e to the power of 0, which is 1. But don't forget about that, it's negative 1. Negative 1 plus 1, 0. So 2 comma 0. And what else would you put in here? Easy number to evaluate. So let's say x is 3. So x is 3, we got 3 minus 2, 1. E to the first power, 2.7. But it's negative. So negative 2.7 plus 1. Negative 1.7. So at 3, it's negative 1.7. Somewhere down here. And looks like if we put in 0, so the number is getting closer to the asymptote. Okay, so let's find out what happens if I put in 0 for x. So e to the power 0 minus 2, so e to the power of negative 2. So e to the power of negative 2 is like 1 over 2.7 quantity squared. So that number is still positive, but it's getting close to 0. But it's negative, so it's going to be negative somewhere. It's getting close to... Okay, so from this region here, well, let's see right here. So 0 minus 2, negative 2. So e to the power of negative 2, so it's 1 over 2.7 quantity squared. Okay, so that number is getting close to 0, but it's negative. So somewhere over here. So this one is showing that it's like a double reflection. Okay, so just want to make sure that this one is correct. If I plug in 2, 2 minus 2, that's 0. E to the power of 0, that's 1. Okay, negative 1, 1, okay. Yeah, so that's right. Somewhere over here. Okay, so double reflection, so that number is still considered positive because you need to add 1. It's negative, but it's negative point something plus 1 is getting close to point something, so it's positive. So it's getting very close to the asymptote, and eventually it's going to be dropping down like this. Exponential decay. And for those you might be wondering, well, what happens if I find the inverse? Well, the inverse, you just need to swap the xy values. So instead of being 2 comma 0, so 0 comma 2. So instead of being 3 comma negative 1.7, so negative 1.7 comma 3. And then this one is going to be exponential decay. Another thing that you need to watch out here, so once you find the inverse, so it looks like this one's going to be like a natural log function. So that means we do have a VA. So instead of using K for the horizontal asymptote, so the VA is going to be 1. So VA is going to be 1, which is right here. Again, for the inverse, that means we need to swap the variable. So in other words, we need to exchange the XY value. So eventually the graph is going to be like this. We do know that it's going to be the natural log, but it's going to be like a declining natural log function. Inverse. Okay, so we try to put this all together so they're like symmetrical with respect to the line of y equals x, the line of symmetry. Okay. And then for the absolute value of f of x. So this one is absolute value. It guarantees that everything is positive. So for this one of the graph, so showing that it's like asymptote. So everything is above. Anything that's less than 2 or equals 2, it's right above the x-axis. So this one pretty much would keep the same thing. And then all of a sudden here, anything after 2, it's going to be negative. So we need to reflect it all the way back to the top. So instead of going down this way, so this one is going to be reflected. So it's going to be going back to the top like this. Okay, so for 3, negative 1.7 is going to be 3, 1.7. Again, this one I just want to keep down the same thing. Okay, absolute value. So find the inverse of the function. So for this one, y equals natural log of x minus 3 to the power of 1/2. Swap the variables, so we got x equals natural log of y minus 3 to the power of 1/2. And then solve for y in terms of x. Okay, so this one, well, bring down the power to the front, so we got x equals 1/2. Natural log of y minus 3. In order to get rid of that 1/2, times 2 both sides. And then convert this one back to exponential form, so we got e to the power of 2x. So that equals y minus 3. And then therefore, the inverse is going to be considered e to the power of 2x plus 3. So log function to the exponential function. And then the rest of this is just condensing, expanding, just like using the property. So product to sum. Well, this one here, it's a sum to product. Difference to quotient, so you want to condense them all together. So log of 4/3 times 20, and then divided by 4 over 15. In other words, multiply by the reciprocal, 15 over 4, and then simplified it. This one can reduce down the number first, so log base 10 if the base is not shown. So 900 over 30, which is 30. And then this one can be written as log base 10 of 10 times 3, expand it, so log base 10 of 10 plus log base 10 of 3, so it's 1 plus log base 10 of 3. Just simplified it. And this one here is all multiplication, so as you can see that it's multiplying, 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 multiplying. But one of the interesting fact is that, so they have like the lower term for the base, and then for the constant, for the quantity, it's always 1 unit higher. Okay, so what we can do, okay, let's see, this one is kind of interesting. So it looks like we can move along the power. Okay, let's see, you try to condense it, so that won't work because that's all considered product. Well, you can make it as a power to another power. So one thing that we notice, so this one is a power to another power, so it's like log base 3 of 4. Again, imagine this one is the coefficient, put it back to the powers like log base 4, 5, and then another power, log base 5 of 6. So basically the 4, the 5, they all got canceled. The 6 log base 6, the 7 log base 7, the 8 log base 8. So what's left here, it's like log base 3 of 9. Okay, so what's log base 3 of 9? So that one is just like 3 square, so it's going to be 2 for this one. And then the rest of those, they're quite similar, so make sure that you need to come up with a common base before you condense, or find out the least common denominator before you combine them. Okay, so try to do the rest of this. Good for practice. And then write log base 3 of a over 55 in terms of a, b, and c, where a is log base 10, b is log base 3 of 4, c is log base 3 of 11. And I do remember that last year in Algebra 2 we did something similar to this. So basically this one you probably want to expand it. Okay, expand it out first. So log base 3 of 2 to the power of 3. And then minus log base 3 of 5 times 11. Or 11 times 5. Okay, like that. Because I have the quantity. And then you want to expand it out. So this one is log base 3, 2. So for that power 3 here, I can bring it to the front. Oh, you know what? Somehow this one... Yeah, the tedious thing is that they put in 4, log base 3 of 4. So let's make it this one as... instead of using 8, so let's say it's 2 times 4. Okay, let's just do one thing at a time. 8. So for that 8, let's split it 4 and 2. Or 2 and 4. And then log base 3, 11 times 5. Just keep it that way. And then expand it again, so log base 3 of 2. Plus log base 3 of 4. Minus log base 3 of 11. Gotta be careful with that. So this one's a plus, but once you expand it, it's gonna be minus log base 3 of 5. Like that. Okay, so log base 3 of 4, then that's what? That's B. Log base 3 of 11, so that's C. And for those you might be wondering, what about for the rest of this? Okay, so log base 3 of 5, log base 3 of 2. I mean, if you multiply them, then that'll be 10, which is A. But those are being separated. Okay, so one is positive, but the other one is negative. I mean, once you condense it, it's 2 over 5, which is 0.4. Oh, you know what? This one can be written as B, this one can be written as C, this one can condense it. So log base 3 of 2 over 5, because that's minus. So 2 over 5, which is considered 0.4, 4 over 10. So expand it out again. So log base 3 of 4 minus log base 3 of 10. So this one's kind of interesting. So this one can be written as B minus A. So we got B minus A for those two. So B plus B minus C minus A. So in other words, it's considered 2B minus C minus A. Okay, so kind of interesting. So it's not that obvious, but the things that you need to play around with those terms, okay? So make sure that they're matching. So the other one, they're quite similar. So try to expand it and find out exactly, what the simplest form is in terms of those letters, P, Q, and R. So this one, finding the domain. So one thing we know, this natural log of any function, so the quantity, it's always greater than 0. Okay, so that quantity x got to be greater than 0. So what that means is that natural log of x minus 1, the outer function, the inner functions, so this one got to be greater than 0. Another thing that we notice, x minus 1 got to be greater than 0 as well. So x got to be greater than 1. But what about for this part right here? So take base e on both sides. So we got x minus 1 is greater than e to the power of 0, which is 1. And then solve for x. So x must be greater than 2. So the other one is greater than 1. Yeah, but this the outer functions must be greater than 2. So that means for the domain, this one got to be greater than 2. Because that we need to make sure is, the domain, there's no any such like a VA there. So greater than 2, so 2 to infinity. And this one, the inner function is rational. So denominator said that x minus 3, x plus 1. Find the VA first. So x cannot be 3. And x cannot be negative 1. And another thing is that this whole quantity must be greater than 0. So we need to find out the restriction for this. And also we need to set that x squared plus 7x plus 6, the nonlinear inequality. So we need to factor, find a possible 0, and then do the sign test. And put in with the restriction. So this one is kind of complicated. And then for c, so denominator cannot be 0, obviously. So that means natural log of x must be greater than 0. And also x got to be greater than 0. So this one's quite similar to the first part. Okay, so x must be greater than 0. And then natural log of this quantity must be greater than 0. So basically you can set that natural log of x greater than 0. So take that base e both sides. So we do have natural log of x. It's greater than e to the 0 power. It's greater than 1. And then take that base e. So x is greater than e. Yeah, I guess this one we need to do the same thing as well. Let's see. Natural log of x minus 1 must be greater than 0. So e to the power of 0. Yeah, let's do it this way. Again, for the inner function, so this one gotta be greater than, well, for this inner function, gotta be greater than 1. But the other one is greater than 2. Instead of doing this way, for a, let's put in that the composition function. For the restriction. So natural log of x minus 1 is greater than 0. So take the base e. So natural log of x minus 1 is greater than 1. And then take that e again. So x minus 1 is greater than e. So x must be greater than e plus 1. It's not just greater than 2, okay? So e plus 1 to infinity. Because one is the inner function, the other one is the outer function, so we have to do it all together. So this one, find the restricted value first, and then put in the whole quantity greater than 0. So you see that which part is either less than or greater than. Again, do the sign test once you list all the possible factors and finding all the zeros. Okay, so that's it. So it's getting a lot more complicated, so make sure that you guys need to rewind and also fast forward to the part of the lesson, the one that you're getting struggle with. Some of the problem, they're kind of tricky, so they're kind of like, related with the property, but they're not that kind of obvious. So the majority of this practice problem here, they're all considered implicit, okay? So got to be very careful the way to apply the property, like this one right here for C. Okay, so some of the function, the way that we sketch the graph. Okay, so thank you for watching the video today. So I'll see you guys next time. Have a great one.